Good morning, Tamina Khan is here in TKMaths is fun. In today's video, we will solve a question on momentum, and it has other aspects also. It is from February-March 2024, M1 paper, code 9709, A-level mathematics, 4-2, mechanics. So you can see the question here on the screen. Important points, all I have resketched here in this diagram here. You can see here, this one. All this, what is written in the paragraph here, I have put it up here in the diagram. So this is the best way. You should always write all the information either in the pointed form on the right hand side of your page, and diagram is must to understand the how you will form an equations. So let's just start. The part 1 of the question is saying verify that the particle P reaches at B with the speed 3 meter per second in 0.5 second. So this is particle P. It is coming here. This is position B. You can see here position B and position A. So particle P is coming from position A to position B, and you have to verify that it will take 0.5 second, and when it will reach at B, the speed will be 3 meter per second. Okay, so now with respect to P, if we see here, according to Newton's second law of motion, forward force minus backward force is equals to ma, right? Because we talk about resultant force. So what is the forward force? That is because of its mass, mg sine alpha, and sine alpha is 0.16 given to you in the question. And it is a smooth surface, so there is no backward force. Okay, only forward force. So now I have simply substituted here the value forward force, mg sine theta, backward force is 0, nothing, ma. So simplified, and I got the acceleration, which is 6. So when object is going from position A to position B, the acceleration was 6 meter per second, but we have to find out what is speed and the time. So I have found acceleration because I need this to apply in the constant acceleration formula, which I have taken here. So now this is the information I have in hand. A is 6, u is 0, distance is 0.75, time and velocity I have to calculate. So now if you see here, I have applied v square equals to u square plus 2as, and v is 3 meter per second after substituting the values. Then I use v is equals to u plus 80, and I got the time 0.5 second. So this is how we will do part A. Now part B. Find the time that it takes from the instant the two particles are released until they collide. Now what is actually happening here? Let me show you here. When this particle, let me take some other color which is prominent, for example this, okay. So when particle P released from here, particle Q released from here, so it happens at the same time. But what happened, this particle P is on the smooth surface for this time, and Q is on the rough surface. So what happened, at certain time they both, for example, collide here. It comes from here and it comes from here, and they collide here at this time. So according to part P, you have to find the time that it takes from the instant the two particles are released until they collide. So you have to calculate this time. Okay, so this is the whole question. So let's see. So for particle Q, I'm doing F is equals to ma, again Newton's second law of motion, forward force minus backward force. Because particle Q is on the rough surface, right, so it will experience maximum friction also, and this is the forward force due to mass. So 0.25 mu is given to you, and how do you get R? If you look at this diagram, at Q the R is here. It is perpendicular and opposite to the plane at the point of contact. So R is equals to mg cos theta, which is this side. Okay, So now you are simply substituting the values in it and you got acceleration 4. So for the rough surface, the acceleration is 4, and for the smooth surface, the acceleration was 6. We have seen that. Now we have to find out what we have to find out, the time. Okay, so now I'm going to substitute here. I'm talking about with respect to q, I have written here sq ut plus half at square. Okay, so u is 0 initially when it started from position B. Acceleration you have just found. So you are basically trying to get here the equation. Why you are trying to get this equation? If I talk about with respect to position B, where is it? Here in this diagram. If I talk about with respect to B, the distance covered by B and by Q will be same. Agreed? So I'm talking about from this point of view, now from this position. The reason is in this area they both were facing the same rough surface and same acceleration. I will not start from here, but it's a different scenario. So this is the reason for it. So I have found the equation of Q from this point onward, that if I want to find out the position of Q, then what will be the equation in which if I substitute T, I get the distance. Similarly, I will find out for P. We have just found in part 1 that P has velocity 3 when it was at B. So that's why I have written U3 and A will be 4. Do not make a mistake of taking 6 here. Okay, 6 was a different situation in part A. So you got the equation here for P. So now you have the equation for S, equation for T. But what is the point to ponder here? They cannot have T. Both of them cannot have T. What is the reason? Because when P reaches here, let me clear this up and tell you here. When P reaches here, Q was suppose already here. And Q has covered how much time already? 0.5. Okay, P is going faster. Now they will collide. But this distance and this distance is not same. So if I'm equating the equation, what should I do? Definitely I should add in Q T plus 0.5 square. Because with respect to this position, Q has taken this distance and the time was 0.5 more, because Q has taken 0.5 second to come from this point to this position. So that's why in the equation of Q, I will write T 2T plus 0.5 square. So now I can equate the distance equation of Q and distance equation of P. So now I can equate these two equations to get the time. Okay, so this is what I have done here. Simply algebraic expansion, and then I will get the time. Now this is the time of P, okay, because we took in our case, okay, this is T, this is T, and for Q it is 0.5 plus T, because Q was at this position already. So when you get T in the equation, it is actually representing particle P. So what you will do for particle Q? You will add 0.5 in it. Agreed? So particle Q took 1 second to come from B to the collision point, and particle P took 0.5 seconds to come from B to the collision point. Now, the two particles coalesce when they collide. So this is the diagram I'm explaining here. It is all with respect to point B now, and this is the position where they collide. You have to find the time it takes from the instant the particle collide until the combined particle reaches at C. So basically you have to find out this time now. So if I have to find out this time, the distance from B to C is given to me is 3.25. So I can use this equation to find out time. But the thing is, do I know S? It means, do I know this distance? U is, what was the velocity of P and Q together when they were moving onward as a combined factor particle. What is that? So this is what we have to find out. So now let's go in the reverse order. Problem we know, using the concept of the momentum before and after the collision. So momentum equation is what? Mass into velocity. So before the system of particle P and Q and after the system, because linear momentum law says momentum remains same of the system before and after the collision. In the question it was given to you that P and Q particle have same mass. So I am considering it as M. So instead of MP and MQ I will write what? M. So once it is M, I can make this factor. Now how will I get this velocity? VP and VQ, this one I have to find out. I don't know this thing. But what about VP and VQ? So let's, with respect to B, what is the velocity when B will reach here before collision? And same is for Q. Okay, so velocity of particle P before collision, V is equals to U plus AT. So this 3 is when particle was at B, and this is the time particle P took to reach to the point where the collision happened, and at that time the velocity was 5 meters per second. Similarly, we will calculate for Q, and the particle Q took 1 second if we consider from the reference point B to reach to the collision, and the speed was 4 meter, velocity was 4 meters per second. Now we know VP and VQ, right? After collision, when they coalesce, what was the velocity? That we will find out. Okay. Sorry. Okay, so in this equation, we are substituting the values we have just found. V5 and V4 here. We are substituting it here, right? And that one will help us to find out the velocity of combined particles. It is 4.5 meter per second. So now we know 4.5 meter per second. Now we need to know the distance. How we will do this? We have to find out this distance. How did I get to here? So this distance from position B to the point where it collides, you can use equation of particle Q or equation of particle P. Both are okay. So I am taking the equation of particle P. S is equals to ut plus half at square. So what was U for particle P here? 3. And how long it took to reach here? 0.5 seconds. And the acceleration was 4. So this helped me to calculate the distance, which is 2. Actual distance was given to you 3.25. I will minus 2 from it. So I will get what? 1.25. So now this distance from the position when the two particles were colliding, from this position to position C, the distance is 1.25, and velocity also I know is 4.5. So now using 4.5 and 1.25, I can calculate the time easily. So I've substituted 1.25 and 4.5. So this is my velocity when particles were combined and moving onward towards C, and this was the distance they have to cover. So it will take 0.25 seconds. So I hope you understood. Thank you very much for watching. Please press like and subscribe button and share it with your friends. Take care. Allah.